let's get on with the topic algebraic fractions. Today we must discuss the algebraic fractions from A to Z, because everybody who needs to solve a problem regarding algebraic fraction, he must know everything of the algebraic fractions and their surrounds. Okay, now before we discuss algebraic fraction problems, we must comprehend what is algebraic fraction is. What algebraic fraction is. Okay, now fractions. I'm going to write type of fractions. Type of fractions. Mainly there are two categories in fractions: numerical fractions. Other one is algebraic fractions. Algebraic fractions. What are the examples for numerical fractions? You know already what numerical fractions are. Fraction like 3 over 8, minus 5 over 6, 7 over 11, and 10 over 3. These are the numerical fractions. But how to form an algebraic fraction? You think that 3 over 8, if I have 3a over a instead 3/8, it is an algebraic due to this symbol, that a. When there's a letter such as A, B, C, D, E, F, English alphabet or any other letter of algebraic term, then you think that I'm going now write to 3 over x. Because of due to that x term, remember, this is an algebraic fraction, right? What are another examples can you have? I can write x over x minus 5. It's also an algebraic fraction, because when there's a algebraic letter, right, it is an algebraic fraction, not a normal numerical fraction, an algebraic fraction. Okay, wait. Then if I have written like x plus 2 a minus 3 over 6. These two are algebraic fraction, right? And again, we can write many more fractions, algebraic fraction, when there's a English letter or any other different letter with numbers. It is called algebraic fraction. Remember, right? In numerator, denominator, if there's algebraic terms, they are called the algebraic fraction. It's clear for you. Okay, now we have to go for the simplification of algebraic fraction. Then to simplify, especially we have to follow addition and subtractions. In addition and subtraction, we must categorize these algebraic fractions into 3 types. First one, denominators with terms. The algebraic fractions having denominators with terms. Algebraic fractions having denominators with expressions. Algebraic fractions having denominators with terms and expressions. Right. Now the doubt coming is the what terms and expressions are. Okay, we will have a clear idea regarding what terms and expressions. Okay, now I'm erasing this. Okay, how do you suppose about terms and expressions? Right, we have to distinguish the difference. Right. Okay, see, terms and expressions. Okay, what are the terms? Terms can be divided into 2 sections: numerical terms and algebraic terms. I am now giving you the basic knowledge regarding algebraic fraction before we do the standard type of problems. I am now teaching you algebraic fraction from A to Z after this introduction. Okay, then you have to wait until I do this introduction. Right, okay. Now, numerical terms, you know, 7, 8, 7, otherwise 6, 90. These are the numerical terms, you know, no doubt. But what are the fractions that can be come through the numerical terms? If I write 1 over 7, or otherwise 7 over 8, like this, these are the numerical terms and numerical fractions from them. Okay, by means of these 6 we can form numerical fractions. Then 6 over 8, 6 over 7, it doesn't matter whatever they, right? But however, these are the terms. What are the algebraic terms? In connection with 7, if I write down further, 7p, yes, an algebraic term. And in terms of 6, if I write 6xy, algebraic terms. 19k square, algebraic terms. Due to that alphabet letter, these are called terms, algebraic terms. It's not terms, algebraic terms, numerical terms, but all they are terms. Then we have to move for the expressions. What are the expressions? Expressions also, expressions, we can get them into two categories, mainly numerical expressions and algebraic expressions. Okay, right, these are not mathematical, these are theoretical. Okay, right, numerical expressions, we can write 3 into 5 like this, or otherwise 3, not 3, whatever it is, 4 times 5 times 7. These are numerical expressions. A lot of times for the algebraic fractions or any other fractions, we don't keep the numerical expressions in this form, but we can introduce the numerical expressions like this and many more. But my topic is algebraic fraction, that's why I'm going to introduce you the algebraic fractions. Wait, now algebraic fractions, there are main two things. One is non-factorable. I'm erasing this. Non-factorable. Non-factorable algebraic expressions and factorable algebraic expressions. Okay. Non-factorable and factorable algebraic expression. What are the non-fact expressions? Then okay, the shape of expression always we have to write an expression at least by participating at least two terms. You think that getting the numerical terms, algebraic terms with the number, this will be an expression, algebraic expression. But by writing these kind of algebraic expressions, you must remember some expressions are non-factorable, some expressions are factorable. Okay, now what are the non-factorable expressions? I will see. Okay, then if I write down a plus 5, has a plus 5 factors? Never, because a plus 5 and having, you think that you have been given 2a plus 10. See the difference, a plus 5 and 2a plus 10. This is factorable, but this one is not more factorable. Therefore, this is called a non-factorable algebraic expression. This will be a factorable algebraic expression. What are the factors that has? Right, okay, we see. Then if I take 2 as a factor, right, how many factors are coming? 2 factors. 2 is one factor, a plus 5 is other. Algebraic expression is also factor. Okay, now in the expressions, in algebraic expressions, you must remember there are two things. One are factorable, other is non-factorable. Okay, one is factorable, other is non-factorable. Okay, if I consider another example, you think, right, if I write down x square plus 9, This x square plus 9, nobody can factorize. Therefore, it's a non-factorable algebraic expression. But if I further write down, I don't have spaces, but wait. X square minus 9, what's happening? X square minus 9 is a non-factorable or factorable? Factorable due to x square is square term and 9 is square term. This has a difference of 2 square method. Therefore, we can have two factors such as 10 x minus 3, x plus 3. How can I take 3 at once? Okay, don't forget. When you see a square term in front, you better check whether there's another square terms after the first square term. Yes, there's 9. 9 is a square number. Then we can form 9 as a 3 to the power 2. 3 is square. Therefore, then difference of 2 square is coming. That's why we wrote x minus 3, x plus 3. But just because of we have a positive sign between the two terms, nobody can factorize this way. This doesn't have factors. Okay? Then we have to totally, absolutely understand what non-factorables and what factorables are, because factors are the main scheme of the syllabus. This algebraic fraction, to solve algebraic fraction problems, so always you have to get an idea regarding denominators of the expressions. Okay, wait. Now we have to go for the do some math problems regarding algebraic fraction now. Okay, now as I told you, there are three categories: the fractions having denominators with terms and denominators with expressions, right? Maybe two type of expressions, and those with terms and expressions both can be participate in denominators of the given fractions. Okay, we will see. Right. Before we go to the first example, I think you have put that note already. Right, I'm now going to introduce denominators with terms. The fractions, algebraic fractions having denominators with the terms. For example number 1. For a over 3 minus, you think that a over 2 I will get. Right? How to do this one? And similarly, if I write down another case, 4a over 3, a over 3, what will happen? It's an additional question. But this is the right question. Right. Before we go to simplify this question, then we have to check the denominators. The denominators has terms. 3 and 2 are terms. Then what kind of terms are there? Numerical terms. Sometimes if there's a 3a, 2a or 2x something, these may have been algebraic fraction. But before we go to the denominators algebraic terms, we have to simplify this kind of small question. Okay, then what is the common denominator for 3 and 2? Because there are two denominators, we can't do a problem having two denominators. Therefore, we must have one denominator instead of them. Okay, what is the denominator? 3 and 2. 6 is the denominator. Okay, now 6 is somewhat larger than 3 and 2, because the denominator you had were 3. Now you have 6. How many times it has been large? How many times? 3 and compared to 6. 6. 3 has been large by 2 times. No? Therefore, how many 3 times? 2. Therefore, the denominator has large by 2 times, the numerator also to be multiplied by 2. That's why we got multiplication 2 times 4, 8a minus, or keep this minus as well. Now compare the denominator you had then, now you have. The denominator you had was 2. Now you have is 6. The what's enlargement? The how many times has been large? Because compared to 2, it has been large by 3 times. Therefore, 3 times 8. The numerator is the same multiple. 3 times 8. Okay. Now, if you have like terms, you can subtract 3a from 8a. What's the answer becoming? 5a. 5a over 6. This is the method. Or otherwise, additionally, if I discuss before we go to this one, 4a over 3, a over 2, we can do adjusting the denominator, or because we got 6 at once, some students are doing writing the denominator as the same one like this. By interchange the denominators, they can multiply both numerator and denominator, and they can create a denominator common. Then 6 is the number, 8a over 6 and 3a over 6. Now answer is 5a over 6. Doesn't matter. But this is the standard method, but however this method is also correct. Okay, now I'm going to give the similar question regarding to this. You say 4a over 3, a over 3. Now the no trouble at the denominators, because the 3, the denominators you have same. Therefore you don't worry about the denominators, because that we have friendly denominators, same denominator, having on the same denominator, no many times large, then 3 is the 3. We have to do what we have the numerator. It's a subtraction. Then we can subtract a from the 4a, it's 3a. Oh no, furthermore we have to simplify 3 and 3. Oh, now the answer has become 2a. Okay, it's a different story regards to this question. I made a algebraic fraction problem having equal denominators, this circumstance. Okay, now we will move to the second example. Wait until I erase this. Example number 2. Right, example number 2, I will give you a question like 5 over 3a minus 5 over 4a square 3 over. I will give you an addition this time. Okay, right. Now check with the denominators. Are there same denominators? Having 3 and 4a squared, nobody can see. Right? The different denominators you have, then you are the one who must have a common denominator, otherwise the same denominator, instead of these two denominators. Now how to find the common denominator? You better use the LCM. LCM. So you know LCM. What do you mean by LCM? 3a, 4a squared. Can you remember the method of LCM? In previous lessons we have discussed the LCM. Okay, generally if somebody needs to get their LCM, they have to write prime numbers and algebraic terms. 3 and a are no problems, but 4 is for prime number, never. Then 4 we have write 2 to the power 2. And a square doesn't change because we need all its powers to have the LCM. And what's LCM here? We have to find LCM. LCM is the common denominator. Common denominator is the LCM. Okay, how to get that? Keep this in your mind. To get the LCM, again I'm reminding, we have to write the different factors that we have here. So what are the different types of factors? 2 is a factor, 3 is a factor, a is a factor. 2, 3, a. Are there any more factors except there? No. Then, but just because of you have the different factors product, not only that, keep the highest powers that they have. Then what is the 2? Considering 2, there's a 2. The power of 2. 3 doesn't have a to the power 1, a to the power 2. What is the highest power? 2. Oh, now it's been the LCM. 2 square is 4, 4 times 3 is 6, a square. Right? Then 6a square is the LCM. Or otherwise, generally, not 6, sorry, it is by clicking at the two denominators according to experience with your past knowledge, somebody can obtain the denominators like 3 times 4 is 12, a and a squares, a square, like this. They are taking their denominators. It doesn't matter, not a problem, but generally, if we want to follow the LCM, that's why I introduced this LCM method, the 12a square. Right, okay. Now, tell how many 3a times 12a square. Then you have to just think about that, because 3a times, because the 3 is the denominator you had, now the denominator you have. How many times? 4 times large. A square. How many times? A times, because it has been multiplied by a. Therefore, not only a, 4 times, a times. Then 4a. 4a into 5, it is 20a. And plus, now you have to check the denominators. The denominator you had 4a square, the denominator you have 12a square. The a square hasn't been large, but 4 and 12, how many times have been enlarged? 3 times. Then, if the denominator is multiplied by 3 times, the numerator is also multiplied by 3 times. 3 times 3 is 9. Okay, now you are going to write, some students especially, 20a plus 9, they are writing 29a wrong. Because the 20a is an algebraic, 9 is a numerical. They don't know each other. Therefore, we have to write and leave the answer as we have. Or otherwise, we can finish the answer like this without writing another step. Then this is the answer. But if we could have written really 20a and 9, if there's 9a only, then 29a could have been written. But this time, nobody can write like this. This is the final answer. Okay. Now we will. No, before we go to the next example, I have to show you some point regarding this. You think that you have been given a question like this? What has happened? Right, especially if you have been that 3a plus 3 over 4a. Now is there any trouble at the denominators? Right, you focus the denominators, don't focus the numerators. For any algebraic fraction, I'm telling you today, for every and each algebraic fraction, you always check the denominators. What about the denominators? Yes, here we have a different denominators. Just because of a you have, you can't say the same denominators. But if you want to have the same denominators, now what can you tell? This is 4a. Then we have the same denominators called 4a. Then I can write 4a, no troubles. And just you have to add 5 and 3 is been 8. And further, if we have simplification, we can do 4 times 1 and 4 times 2. What's your answer? 2 over 8. This is the answer. Okay? But this question is given in addition to this one. This is my main question, because algebraic fraction having equal limits are always easy for students. I know that. That's why I am additionally giving this. Okay. Now we will skip to the example number 3. Okay. I will give another example. 9 over 4a square minus 5 over 2ab. Oh no. What is going to be here? Right. Check whether the denominators. Right. Oh, what did okay. I have to ask you a question. When you see an algebraic fraction problem, what is the main part that you should watch? Always, but denominators. Check whether the denominators are same or different. Now you have different denominators. Then what should you do next? We have to create a common denominator. To get a common denominator, you have to follow LCM or any method that you know, and or otherwise you have experience. Right. Then with the according to experience, then you can have the denominator as 4a square b must be the denominator. But some students are not doing so. The thing is that just because I mentioned the denominator with my experience, some students are very talented to have this denominator without doing any calculation. Yes, they are having a 4a square b. That's their talent, right? But whatever the talent or skill, it doesn't matter. There's maths. Right, the mathematically we can prove the denominator as 4a square b. Okay, I will write here 4a square b is the denominator. How to get that? Common denominator must be there. Right, okay, I must write a 4a square and 2ab. Okay, can you remember? This is the LCM. Because separately, if there's a question like to find the LCM, this kind, you must know. Okay, we'll see. And what should I tell? I told you about a 4 is not a prime, therefore I have write 2 square and a square, 2 is a prime, good. A are the different algebraic fraction terms, sorry, fraction terms. Okay, now LCM, how to find out LCM? We have to write the different terms. What are the different terms? Denomination 2ab. Show me if there's any other terms except 2ab. No. Right, therefore 2ab. Right, okay. 2 is there, a is there, b. No any other like term like c or not. Okay. Right, but however, having written down the terms, all the different terms, denominations, the next thing is you have to find the highest powers that they have ever. Right, what are the highest powers? They're looking at that 2 square, 2 squares there, and a square is there. B doesn't have a power. No need, okay, doesn't matter, right? What is the 2 square? 4 and a square and b. That is what the denominator I earlier mentioned. Then 4a square b. Right, okay. Now you have to compare the denominator you had and what you have now. Right, what's the denominator you had for a square? The denominator you have now for a square b. But how many times had been enlarged? 4a square to 4a square b. It has been enlarged by b. Right, therefore you have to multiply by b. The b times 9. 9b. Good. Compare the LCM. Right, the denominator you had 2ab. The denominator what you have, the 4a square b. Right, 2ab, 4a square b. How many times had been large? Little bit you have to compare, no? Because the numbers 2 and 4. 2 has become to 4. How many times? 2 times large. In letters, b is, doesn't matter. A is not a. A times large. Then how many times? 2 times you told, a times you told. Then how many times? 2a times. If the denominator is better to multiply by 2a times, isn't it better to multiply the 5 by 2a times? Yes, we must. Therefore, 5 times 2a, 10a. Right, I'm going to simplify. I feel like to subtract 10a from 9a. I feel like minus 1b or stupid something, but all it on stupid. Some students are writing like this. That's the thing. I can't bear that. Remember, when you have unlike terms, unlike algebraic terms, nobody can simplify because b doesn't know a doesn't know b. Therefore, nobody can add these two terms or subtract. Then we have to phrase the answer like this. This is the final answer. No more simplification. Initial letter. Okay, right now this is the example number 3. Right, but however, I have to give a similar question. Wait. Okay, now you will suffer what I am going to write. Right, 9 over 4a square and 5 over 4. What should I write? 4a square. Then we can do this. And when you subtract 5 from 9, yes, 4 over 4 is going to or otherwise equal division 4ab 4ab. Doesn't matter, right? All right. Okay. Now I don't go to teach this anymore. Reason algebraic fraction with equal denominators are easy lesson. But now I had to discuss example number 4. Wait. Example number 4. Right. Now I'm still in the topic number 1. Right. I will get this as the final question, final example under the topic number 1. Okay. Wait. 4. I will give you question number 1 over 3 over 2xy and minus 1 over 4x plus 1 over 6y. Okay. Here, this question contains 3 algebraic fractions. We have to simplify these 3 algebraic fractions together. How to do? Thing is, don't get upset with this problem you have. Reason, large question, long question, but 2xy, 4x and 6y. 3 denominators together. Instead of these 3 denominators, we had to make a 1 denominator. Let's find the LCM. Okay. what is LCM? Generally, by your experience, we have to manage the LCM. So what's LCM as you suppose? The LCM, because the 2, 4, 6 should be 12 as a number. The 12 should be the experience. Then X and Y. This 12XY is the LCM. But however, all the students don't know the 12XY is the LCM before having. Therefore, I will again remind you how to have LCM. 2XY, the 4X and 6Y. Right? If I write down 2XY is the 2 times X times Y. 4X. 4 is not a prime. Therefore, 4 is written 2 to the power 2 and X. 6 is written. 6 is the 2 times 3 and Y. What I asked was, right? Now you remember the 12XY we don't know at the moment. Right, but now LCM. Some method to get the LCM. To get the LCM, we are writing different factors that we have. What are the different factors? 2 is a different factor, 3 is a different factor, X is a factor, Y is a factor. Right? Okay, with all varieties I wrote, we must find highest powers that they belong. Considering 2, the highest possible power is 2. But 3 doesn't have, X doesn't have a power, Y doesn't have any power. Therefore, the LCM is this. Right? Then what is LCM? Different factors with their highest power. Right? Then you have to get the product but. Okay? Right. But however, 2 square, 4 times 3, 12, X, Y. Okay? Now LCM is 12XY. Then what is the meaning of LCM? The LCM is the common denominator instead of these 3 denominators. Right? But however, this common denominator always going to be large, because considering 2XY and 12XY, how many times they have been large? 6 times. Therefore, if the denominator large by 6 times, you have to enlarge the numerator by 6 times. Okay, 3 times 6 will be 18. Minus doesn't change, minus is minus. How many 4x times? Then how to get? You had 4x, but now you have 12xy. How many times had been large? Considering 4 and 12 by 3 times. And x hasn't been large. And y, because there wasn't y, now you have y. It has been large by y times 2. Okay, now you told 3 and now you are taking y. 3 and y, 3y. It has been large by 3y times. Then 3y times 1 is 3y plus. Okay. Now you compare the denominator you had 6y. The denominator now you have 12xy. The how many times it has been large? 6 and 12, 2. And y hasn't been large, but there's additional x term. Therefore, 2 times and x as well. 2x is the factor that had been multiplied. Therefore, denominator has been large by 2x. Therefore, 2x into 1. 2x. Okay. Now you must check whether there are possible simplification in the numerator. Yes. 18 and 3y and 2x. All the 3 different terms you have. Therefore, 3y doesn't know 18 or 2x doesn't know anything. Therefore, we have to complete the answer like this, because no more simplification. If you wish to do, no. Right? Don't go to do so. Okay. Now, so far we have discussed the fraction having term denominators. But again, we have to move to the second topic. Okay, we will skip to the second topic. Second topic, you have algebraic fraction having denominators algebraic fraction having denominators, otherwise I am writing denominators expressions. This is the second topic. Okay. Okay, how to discuss? Right. To discuss, I must take an example. Okay. My first example, 7 over x minus 5 minus 2 over x plus 3. In addition to this example, then additionally I will give you 7 over x minus 5 minus 2 over 3x plus 9. Okay. Now, can you remember in expression, according to my first explanation, I gave two types of expressions. Mainly in algebraic expressions. Okay. In algebraic expression there were two, factorable and non-factorable. Right. Looking at x minus 5 and x plus 3, you will definitely feel these two factors are non-factorable. But looking at x minus 5, one is non-factorable but 3x plus 9 is factorable. Then we have more factors. Until we have the factor, we cannot start the problem. That's what you have to highlight and you have to learn. Okay, therefore, first question is very easy. The reason, non-factorable factors we have. Therefore, just you have to get the LCM or otherwise easily the product between the two expressions, because x minus 5, x plus 3, they don't have factors, then product of the factors is the LCM. Because as I earlier mentioned, if I write down x minus 5 and x plus 3, these two terms are all, remember, these are non-factorable. Okay? Right, therefore, the different factors is the product. The product of different factors is the LCM otherwise. That's why. Okay, now, according to the denominator you got, then you have to find the answer. Right, here, this question, before we go to complete this one, I am going to discuss this. The thing is, we are unable to start yet. Reason, this trouble. What's the trouble? You have 3x plus 9. Therefore, 7 over x minus 5 minus 2 over, this one is the factorable factor, therefore expression. Then 3 is the factor, x plus 3. Now it has totally factorized. Therefore, now we have non-factorable denominators, because x minus 5 non-factorable, 3 is non-factorable, x plus 3 is non-factorable. Therefore, now we have to have the denominator. What's the common denominator? 3 is a different factor, x minus 5 is a different factor, x plus 3 is a different factor. It doesn't matter for change in x plus 3 and x minus 5. If you wish to get x plus 3 with 3, doesn't matter. But however, 1, 2, 3, all the three factors should be laid as the common denominator. Are you okay? Right. Now, that's when we have to discuss how to get an answer. Okay. Now with the denominators in the both circumstances, then we have to have. Okay. I will discuss first. Right. This one main question. This x minus 5 x plus 3. Now again, you have to compare the denominator you had and new denominator you have now. You had x minus 5. Now you have more than x minus 5. What? X plus 3. Therefore, the x minus 5 had been multiplied by x plus 3. Therefore, it's unfair. You have to multiply the numerator by the same x plus 3 to get the same denominator. Therefore, the additional lead has been x plus 3. You have to multiply this 7 by x plus 3. That's what I am writing. Are you okay? And minus is minus. Again, you compare the denominator you have and now we have. Okay, have. And x plus 3 cancel. What's remaining? X minus 5. How? Because you had x plus 3. Now you have x minus 5 other than the x plus 3. Then denominator had been multiplied by x minus 5. You have to multiply by that. 2 times x minus 5. Are you okay? Right. Now, you have to just remove the brackets here. 7 times x, you know, 7x. 7 times 3 is 21. And minus 2 times x is 2x. And minus minus plus, you know, 2 times 5, 10. And what's your answer? The denominator is denominator. It doesn't change. And we have to simplify the like terms together. Here we have minus 2x plus 7x. Your answer is plus 5x. What is plus 21 and plus 10? Plus 31. Okay. Now we have to keep the denominator remain. X minus 5, x plus 3. This is the final answer, right? This is the answer for the first question. But here, with respect to this 3, also we have to continue. Will be a different answer, it doesn't matter. But however, we'll see. You compare the denominator previously you had and what you have now. Denominator you had was x minus 5. But now you have 3 and x plus 3 other than x minus 5. You have to multiply by this 3 and x plus 3, this 7. I will indicate that 7 is multiplied by 3 and x plus 3. Carefully you have to watch, right? X minus 5 you had, but you have additionally now 3 and x plus 3. I multiply that 7, 3 and x plus 3. And minus 2 is 2. It is coming always. And but denominator you had 3 x plus 3. Now you have 3x plus 3 or yes, additionally you have x minus 5. You have to multiply this numerator by x minus 5. Okay, now this is mathematical. We have to remove the brackets. You know how to remove the brackets, but before you go to remove the brackets, you must know this is a product between 7 and 3 is 21. 21 times x and 21 times 3, of course. Okay, 21 times x is 21x. 21 times 3. You suppose 21 times 3, 63. And minus 2x. Minus minus getting plus 2 times 5 is 10. What's your answer? 3 times x minus 5. The denominator never changes. Right. Collect the like terms. Collecting like terms. What's the like terms? Yes. 21x and minus 2x. It is 19x. And positive 63 with positive 10 is positive 73. Positive 73. And the denominator. Okay. This is the answer. But what I focus from the first question was to compare the denominators. When the denominators have expressions, algebraic expressions, you must check whether the denominators are factorable or non-factorable. If the all denominators are factorable, non-factorable, the denominator is the product of the expression that they have. But if one or two denominators have factorable, you cannot start the question until you have factors. Always that we have to write the denominator in factor forms when there are factorable expressions. That's what I focus from the two questions, and simplification is the same. Okay, but now we will skip to the question number 2. Example number 2. Okay. Example number 2, I will give 3 over 5, 2 over a plus 2. And additionally, I am writing 3 over 5a, not 5, and 2 over a square plus 2a. We have to distinguish the cases in the two occasions. But under question number 2, I am giving the differences. Okay, the differences of denominator is the thing. Okay, now looking at the second question mainly, what do you have? You have non-factorable expressions as the denominators. Therefore, when you have non-factorable, just you have the product 5a plus 2. Or otherwise you find the LCM according to your knowledge. LCM is the product of the different factors with their highest powers. Fortunately, they don't have powers, therefore we have to keep the product of the denominators. Okay, right. Now, having the denominator, we have to simplify. Simplification is up to you, but the thing is, what I focus the denominator cases. When we have factorable denominators, looking at 5a, 5 and a are two factors, but living together, but a square and 2a, it's also a factorable expression, therefore you cannot start this question yet. Then we have to do a small change. Okay, before you start, then you have to make the change at the denominator. How to change the denominator? Having the factors. Okay, what's the factor? Common factor you have a square and 2a. A is the common factor. Therefore, a plus 2. Okay, now all the denominators 5a as well as a plus 2 are non-factorable. That means all the expressions have given factors. Okay, now what are the different expressions, different factors that you have at the denominators? 5 is a different one, the letter a is a different one, different term, and a plus 2 is another different expressions. Are there any highest powers or power? No. Therefore, don't worry about the power. That is the common denominator. Right. Now, according to this denominator, now you have to compare the denominators you have and what with you now. The 5a and 5a times a plus 2. The denominator you had have been multiplied by a plus 2. Therefore, numerator is also multiplied by a plus 2. That's why we are indicating a plus 2. Plus, okay. Now, see, the denominator you had and now new denominator you have. A times a plus 2, a times a plus 2, additionally there's 5. Therefore, you have to multiply this numerator by 5. 5 times 2, you can think and write 10. Okay. Now mathematical. This expression is mathematical. We have to mathematically remove the brackets and simplify according to your knowledge. Right. 3 times a. 3a. 3 times 2, 6. 3 times 10. Sorry, not 3 times 10 because the brackets are closed. The 10 is 10. Okay. Right. Now 5a. A plus 2. Okay. What's the answer going to be? 3a. 6 and 10, 16, 5a, a plus 2. This is your answer for the question. So what is the hard out of the two occasions? Right hand side. This type of questions are the questions coming mainly for the exams. But these kind of small questions are also coming. But students always should comprehend the differences between the two questions and denominators, especially what I focus. Okay, right. Now we will move to another example. Right. Oh, I didn't do that. No. Okay, may I do this? Okay, before I go to the next. Okay, right. I forgot to do that. Okay, right. Now tell. Yes, you had 5. But you have 5 times a plus 2. Then additionally a plus 2 is there. And you multiply by that. 3 a plus 2. And try to plus as plus. And compare the denominator. You had a plus 2. Now you have 5 times a plus 2. And additionally you have 5. Then 5 times 2 getting 10. And what's the answer? 3 times say 3a. And 3 times 2 6. And this is 10. What's the answer? 3a plus 16, 5a plus 2. Right? The one and only change is it had been multiplied by denominator had been multiplied by simple a other than the first one. Okay. Example number 3. We have a different question. 3 over p plus 2 plus 4 over p plus 5. And regarding this, I am going to give another small change. Okay, it's a dangerous change actually. Right, if I give you this 3 over p square minus 4 plus 4 over p square plus 5b. right? Then compare the denominator. What's the case where we have? In two cases, right? Mainly you have to focus towards the denominators. Otherwise you cannot start a problem. Then p plus 2, p plus 5 are non-factorable. But denominators we have here, p square minus 4, p square plus 5p are totally factorable. This p square minus 4 you will feel according to past knowledge, and difference of 2 square something, can you remember? And p square plus 5 we have a common factor called p. Therefore, these two expressions are factorable. But p plus 2, p plus 5 are further non-factorable. Therefore, this question is easy. This question cannot be started yet. Right. Then we will do this first. Okay. Let me have the denominator. Here's expressions we have. P plus 2 is a non-factorable one, and p plus 5. What's the product? Then you have different expressions, different factors. P plus 2 is a different factor. P plus 5 is a different factor. Right. Now look, having the common denominator, you compare the denominators you had then what you have now. Okay, p plus 2, p plus 2. What is additionally? P plus 5. You have to multiply this denominator by the additional denominator you had. Okay. And plus, keep remember. And p plus 5. Now you have p plus 2, p plus 5. Then p plus 5, then other than that p plus 2 is there, you have to multiply 4 by p plus 2, and you have to remove the brackets. Okay, 3 times p, 3p, 3 times 5, 15, 4 times p, 4p, 4 times 2, 8. Okay, and p plus 2, p plus 5. Are you okay? Right, now tell me, 3p and 4p, what's the answer? 7p. 15 and 8, 23. And your answer is completing p plus 2 with p plus 5. This is the answer. Okay, but at the right hand side, it is not an easy one. Reason, denominator. The case of the denominator is affecting you. Therefore, we have to first solve the denominator case. And because, as I mentioned, I gave a point factorable. Therefore, further we have factors. We must have factors before we go to start the question. Okay? Right. Then what are the factors? Right. P square minus 4 square. 4 square is written as 2 square. You suppose by your mind. And p square minus 2 square will be difference of 2 square. P minus 2, p plus 2. Right? Right, if you are not okay with what I have written, then you better change like this. Instead of 4, I have written 2 square. Now you will see p minus 2, p plus 2. Right? No need to write somewhere else, but I wrote. Okay, 4 is 4. Now, what's the common denominator? P square plus 5 will be, common factor. P is a common factor and p plus 5. Right? Tell what's the common denominator? Common denominator, then all the factors with their highest powers. What are different factors that we can see? P is a small factor, and p minus 2 is another factor, and p plus 2 is a factor, and there's another different factor, p plus 5. Oh no, right? We have to do more, no? Right. Looking at the denominators, then you have to carefully simplify. Okay, right? Help me. Right. P minus 2, p plus 2 you had, but what you have now is very much longer. P minus 2, p plus 2, p minus 2, p plus 2. Other than that, you have p and p plus 5. It has been enlarged by p times p plus 5. Then you have to multiply, you have to get enlarged with 3 with this factor. Therefore, 3 times p plus 5. Plus, with the denominator p plus 5. Now you have p minus 2, p plus 2, p plus 5. But the denominator you had p plus 5. Now you have p minus 2, p plus 2 other than the p and p plus 5. Therefore, you have to multiply 4 by p minus 2, p plus 2. Okay? Right. Now we have to remove the brackets. This is a single term 3p. 3p times p. 3p square. 3p times 5. 15p plus 4 times. You have once again p minus 2, p plus 2. Therefore, you have to reduce this p minus 2, p plus 2. Then vice versa, you have to think back. How? Because this is the answer of the difference of 2 square. If you go vice versa, it is written p square minus 4. Right? You suppose that? Because that when you have, if you have this p square minus 4, you are writing p minus 2, p plus 2. But when you have p minus 2, p plus 2, then we can concise this to the problem that we initially had. Right? P square minus 4. Right? This is an exact expansion. Now we have to reduce that. Okay? Now the denominator doesn't change. P minus 2, p plus 2, and p plus 5. Okay, the whole simplification here. Right, now I'm going to erase the problem and continue the steps. Right, now tell. Before we go to simplify, we have to remove this bracket. Therefore, then 3p square plus 15p plus 10. 4 times p square, 4p square minus 4 times 4, 16. And the denominator you have p minus 2, p plus 2, and p plus 5. Okay. Right. Continually. Now we have like terms. Looking at the p square, we have like terms 3p square and 4p square together 7p square and 15p minus 16 over p times p minus 2, p plus 2, p plus 5. Okay, right. This is the answer. Or otherwise, then if the expression at the denominator has more factors, you can keep the factors also, or otherwise you can limit the answer like this, because for the grade 10 we don't expect more simplification, because the thing is whether you are able to find the LCM and simplify. Then if you have more factors, you can factorize. If you want to factorize, we know 16 4 times 4 and 8 times 2, with those factors you can check whether possibility to make a 15. Right, okay. But however, we can stop the answer like this, or otherwise we can continue this expression as factors if the expression have factors. Okay, then you have to check whether they are factors. Okay, right, or otherwise we can limit. Okay, now we have to go for the next example. Right, we will get another example. It has 4 over x plus x minus 2 minus 3 over x plus 4x minus 2. But at the question I have given in the left hand side, you don't have more factors, because x plus x minus 2 non-factorable and x plus 4x minus 2 non-factorable. But with what we have in the right hand side in connection with the problem I gave, you have factorable expression at the first expression, but the second one doesn't have factors. Okay, therefore we have to do first the left hand side one. We can because start this, but this one we are unable to start until we have factors of the non-factorable expression. This one is factorable, this is non-factorable. But in the first question, we have non-factorable expression, therefore we have LCM easily. Then what are the LCM? How to find the LCM here? To find the LCM, we have to collect the all different factors. Then x plus 3 is a different one. X minus 2, then only one x minus 2 can be taken as a different, and x plus 4. Are you okay? Right. This is the common denominator, but you check whether is there possible power. No, nobody has the power, therefore we don't take powers. Right. Now compared to the denominator you had and with the denominator now you have, you see x plus 3, x minus 2, x plus 3, x minus 2, x plus 4. The denominator you had been multiplied by x plus 4. Then also numerator is multiplied by x plus 4. Therefore, you write 4 must multiply by x plus 4 minus, and compare the denominator you had x plus 4 x minus 2, x plus 4 x minus 2, but other than x plus 4 x minus 2 we have x plus 3 had been large, therefore you have to large by the x plus 3, this one. Okay, now what should we do more? We have to do maths, because in brackets 4 times x you are writing 4x, and 4 times 4 you know 16, minus 3 times x you know 3x, and 3 times 3 9. But you must remember minus into plus giving minus, 3 times 3 is 9, and denominator is denominator, right? Okay, we fill in the blanks. So x plus 3, x minus 2, x plus 4. Okay, now then we have like terms. Looking at the 4x and negative 3x, positive 4x and negative 3x, x, and positive 16 with 9. What's the answer going? The answer is, when you subtract 9 from 16, what's your answer? 7. Positive 7, majority is positive, and the brackets. X plus 3, x minus 2, x plus 4. Okay, this is the final answer for the question. Okay, we will consider this regard. What's happened? I thought that this question is unable to start, yet reason this is more factorable. Therefore, until we have the factors, we can start the question. Then we have to write with what we have in the problem, like this. Okay, now have the factors. It's a quadratic expression. In quadratic expression, you must have basic knowledge to factors, because in early lessons we must have discussed this kind of factorization methods. Okay, in order to quadratic expression, we must always find x squares xx. That's a short method. Okay, and 4 is written 4 times 1. The 4 is the 4 times 1. But by means of 4 times 1 and x times x as well, we have to check whether 5x is written. Yes, 4x, 4 times x, and 1x, 5x is come. Therefore, we have to write, because the demand is minus, to make minus 5x, we must know when there's a last term is positive 1, the brackets may have positive, positive, or negative, negative. Otherwise, plus, plus, so minus, minus. Then minus, minus is kept according to the minus 5x, because minus 4x, when you multiply x and minus 1, minus 5x. Okay, now we have absolutely factorized the denominator. Right? It was factorable, now it is not factorable, non-factorable. Right? Now we can start the problem. Now only we are going to start the problem. Right? Now to start the problem, we must have a common denominator. What's the common denominator? Let us write. X minus 4 is a different one. And x minus 1, then out of the two expressions same, we have to write 1. And x plus 2. Are there any differences? Are there any different expressions? No. There are no different factors. Okay, this is the common denominator, and compare the denominator you had and with what you have. Okay, now you had x minus 4, x minus 1, x minus 4, x minus 1. What's? Yes, additionally x plus 2 is there. You multiply this 1 by x plus 2 plus, and compare x plus 2, x minus 1 you had, x plus 2, x minus 1, and x minus 4 additionally you have. Then this denominator you had as multiplied by this x minus 4. The numerator is also multiplied by x minus 4. Therefore, x times x minus 4. Okay. Now in the same case it's okay. Now we have to do maths further. 1 into x, x. 1 into 2, x into x, x square, x into 4, 4x, and have the brackets. Further, we can collect like terms together. Because of this x and x square, the x square is the main term, because for a quadratic equation, for a quadratic expressions, we have to write quadratic terms at the beginning. and x and minus 4x. What's the answer? Minus 3x and plus 2. The question is going to be over, but I don't think so, because definitely anybody can guess this numerator will have factors, because with the factors when we see we can stop. If we want to stop, then it's okay, but further if there's possible simplification we must go. Okay, right, now that's what I am going to continue. Right, wait, the further simplification there. What's happening now? Simplification, in addition to the denominator you wrote, what was the denominator? X minus 4, x minus 1, x plus 2. I am writing x minus 4, x minus 1, x plus 2. Okay, and tell you had x square minus 3x plus 2. We can factorize over there. X square minus 3x plus 2, how to factorize? You know, basically x square is written xx, 2 is written 2 times 1, no, otherwise 1 times 2. It doesn't matter. 1 times 2, 2 times 1. Oh, right, we have to make minus 3x, yes, plus 2x and 1x there. But according to last term plus, the rule is plus plus or minus minus. We have to write minus minus because minus 2x minus 1x getting minus 3x. Right, now, is it all over? No, because looking at the expression further, we have a common factor to cancel. Right, now, what's the answer? X minus 2, x minus 4, x plus 2. Are you okay? This is the answer for the question I wrote at the right hand side. Okay, now we have to move to the final example, somewhat hard one. Okay, we will discuss. Right, wait. Right, it's a question, new question. I will go to simplify 3 fractions with algebra. Right, this one. How to do? Okay, just because of you see the problem, don't go to start. You follow the way I gave. What did I give? You have to check the denominators. Factorable, these two, yes. Factorable, x minus 1. No factors, non-factorable. Therefore, we can start the question yet. Reason we have to have factors of the denominators. Right. 2x minus 1. And what are the factors? It's a quadratic. Minus x. Yes. What are the factors? Minus, this is non-factorable. We still didn't start the question, right? Okay, because we are pending, we are waiting to have factors. Okay, tell what are the factors to come? The x square plus x minus 2, you know, x square is written as xx. 2 is the 1 times 2, otherwise 2 times 1. Right, now with the last term minus, if last term minus, signs are plus minus or minus plus. But if the midterms get in plus and plus minus, then plus 2x minus 1x, when you simplify, plus x is coming. That's how you have to factorize, right? I don't go to discuss how to factorize the quadratic expression this time. Reason, this must be learned previously before you come to this. That's right. Okay. Right, now 1 minus x square. 1 minus x square, you know, 1 minus x, 1 plus x. What's happened? It was a difference of 2 square. How did you suppose that? Because 1 is the 1 square squares. See, 1 square, you know, 1 square minus x square is the difference of 2 square. Because 1 is 1. Right? 1 square is also 1. That's right. Okay? Right, then we can write 1 minus x, 1 plus x. That's how I suppose that answer. Right, this is non-factorable. Okay, now we can go to the have a denominator, but before that I can see a abnormal denominator 1 minus x, because I think it's better to have x minus 1 other than 1 minus x, because according to the algebraic expressions we must always write algebraic terms in front and numerics after that, like that. Okay, when we have a 5 minus 6, then I think most we prefer x minus 5 is better. But 5 minus 6 is not x minus 5. There are strategical steps to follow a negative sign. Therefore, that's what we have to remember. I will give an additional note. Remember, when there are abnormal expressions like them, then follow this. Remember, if we have an expression like b minus a, how can you write? When algebraic fraction and every relations, when you have b minus, if you want to change, you better write a minus b, but keep a minus sign in front. If you have 5 minus p, how to write? Yes, p minus 5 have a minus sign, right? Okay, you follow. 3 y minus x, how to write? This is minus 3 x minus y. See what's happened. Y minus x I wrote as x minus y, no doubt. But positive 3 will be negative. If there's a negative 3, that will be positive. It's effect with the negative sign in front. Okay, right. Then if there's a negative 3, this should be plus. If there's a positive 1, this will be minus. Have this note, okay? Right. Okay, that's what I'm now going to do, because having x minus 1 in one denominator, I can't bear that 1 minus it. I must have x minus 1 somehow. That is better for now. Right, therefore, we can change. Then, are we starting it? No, we can't start this, because we are now make some arrangements in the problem before we go to the start, right? Okay, now 2x minus 1, x plus 2, x minus 1. Now, what I am now going to do, to arrange this 1 minus x as the I discuss. How? x minus 1, 1 plus x is x plus 1, doesn't matter, because for positive expressions I didn't write something like that, because 1 plus x or x plus 1, the positive expressions are same, right? But negative expressions are totally different, that's why. Okay, but however, because of this change, what's coming in front? There, if there's a minus what I told, there should be positive. Definitely you must learn this as a positive sign. Don't forget, this is effectable, right? Positive, right? And this minus x minus 1. Okay. Now, we can easily select the denominator. Okay, see the different expressions. X plus 2 is a different one, and x minus 1 is a different one, x plus 1. That's all. This is a different product. Okay, right, now the product of the denominators also. Okay, now we have to find the answer. How to find the answer, right? You compare the denominator you had and with the denominator now we have. Okay, x plus 2, x minus 1 were there. Now x plus 2, x minus 1, more than that we have